Hello everyone, this is Prashanth. Let's continue with the last lecture on question bank discussion on some various topics from module 3. This is also one of the top question bank discussion on the module 2, that is IoT system management and simple network management protocol. So here the IoT system management, IoT system IoT system management. This is one of the domain topic, and SNMP. So under protocol, simple network management protocol, simple network management protocol. So this is one of the type of protocol in order to do the performance activity inside of the network. So these are the two topics I am going to explain. So here these are the some questions based on IoT system and IoT system management and simple network management protocol. So here they extend the need of IoT system management with suitable. This is one of the question. List out the limitations of simple network management protocol with suitable examples, and list out the limitations of conventional network architecture. So like before going to explain the before going to know the software defined networking, first we have to know the some limitations of traditional network architecture. So in order to overcome that, just we move to the software defined networking. So that is the process here, and interpret the development process of wave of things with suitable example. So after internet after IoT, so WOT also one of the topic will existing here, wave of things, and explain the importance of network wide configuration and IoT system with multiple nodes. So like different specifications. So these are the some question bank questions we may raise on the question bank of the Internet of Things subject. So here let's start with the main actual content of IoT system management. It having automatic automation configuration, monitoring operational and statistical data, improved reliability, system-wide configuration, multiple system configuration, retrieving and reusing configuration. So these are the important specifications before going to explain IoT system management. It can automatically connect to the system while the network is available. That is the automatic configuration of the device, and monitoring operational statistical data. So the what are the operations is going on in the network, and it can based on that recorded data, just we can do the analyze, and it can define the statistics of method. That is the next one. Improve reliability also, just we can improve based on that our requirement, and the system wide configuration. So it is not deal with any narrow configuration, so it can deal with the wide range of configurations of the devices, and not only end with single, it having multiple system configurations. That is the based on the requirement, and the retrieving and reuse configurations also exist in the IoT system management. So these are the some questions. So here managing multiple devices within a single system requires advanced management capability. So here just we already know here multiple system configuration. So in order to perform this task here, just we use advanced management capabilities. So what are the capabilities here? Automating configuration, monitoring and operation, just we already discussed in the last slide. Elaboration of these things here: automatic configuration, monitoring operational and statistical data, improved reliability of the system, and system wide configuration. It's consists of multiple devices and nodes, ensuring the system wide configuration can be critical for the correct functioning of the system, and multiple system configurations. For more systems, it may be desirable to have multiple valid configurations which are applied at different times or in certain conditions, and retrieving and reusing configurations. So here my management systems which have the capability retrieving configurations from devices can help in reusing the configurations for other of the same type of the data. So these are the minimum things we have to know. Next, how the companies oversee the device management. Just can it can some capabilities of the devices. Companies have been using Internet of Things devices for a long time. For agriculture companies, monitoring weather and crop conditions to industrial companies, tracking the output and safety within the manufacturing facilities. So that is the how companies oversee the IoT devices management. So in the basics of that one is provision devices using standard provisioning protocol. So in order to do the some kinds of certain kinds of operation, just we how to follow the standard provisioning type of protocols, and take extra care when adding legacy technology to the network. So that is the second one. And take failure into account when planning device orchestration. That is next one. And educate employees on cyber security good practices. Just to, from the childhood only, just we have to do the developing up the abilities. How can manage the threats from the cyber security, like that. And adapt to zero trust to security measure. Choose low maintenance device. It is not to her just we can highlight with play with low high maintenance devices only. Just you have to choose the low maintenance device and you can remove from there, like that. And the last one, train and upskill employees on IoT device management. So these are some basics. Let's see one by one. So here, provisioning devices, the first step in IoT management, very important. For slogan that you want to find a simple way in which you cannot think standard and go for there. So this is the provisioning devices. It is incorporated to in company's existing suite the IoT devices before they can be used. So doing that successfully for new devices takes several steps, starting with IoT system identifying each new device. So this is the first one. And the second one, orchestration needs to take failure into the system. For that, just we have one here one sentence. It's not just the devices, it is also the computers and the servers and various other elements that you have that make up your system. So that is the orchestration need to take into failures. The Mailer scientist said the second step of the IoT device management process and orchestration, which makes sure connected devices that are able to work together properly can be controlled centrally. That means configuration more than just the IoT devices. So this is the second one needs to take failure into the system. And the third one, securing IoT devices against attackers. So the settings for this in this board aware of this issue. In this board investing in this issue, it is putting money where it needs to be located. So here the security is a big concern in the IoT world. Insecure devices can easily let hackers penetrate systems and access sensitive information, like that. So this is the third one. And IoT devices should allow flexibility in management. So it will follow or it will allow the flexibility according to our requirement. Just it maintain allows for flexibility of the system. It tends to the focus on technology, but what many tend to forget is the people of the equation. So that is the some slogan. It can be daunting to manage a large fleet of IoT devices, but companies can set up devices so updates don't take as much time. Carnera from 4Kites recommends that companies that think outside the box when choosing the devices. So this is the fourth one. And remaining IoT device management, what is this, what is it, and why do you need it? So that is the significance of the IoT device management. So here just we have to follow the, or we have to explain these 3-4. It refers to all of the tools, capabilities, and the process necessary to support IoT solutions effectively at scale. So included the process like quickly, securely onboarding new devices, automatically identifying device issues, and etc. So this is the about IoT device management, some introduction points. Again, it is for provisioning and authentication, configuration and control, and monitoring and diagnostics, software maintenance and updates. So these are the four kinds here. Let's see, start with the one. When adding new IoT devices, you want to make sure that only trusted, secure devices can be added. So you would not want bad actors to be able to connect devices to your IoT are not genuine. It is the trusted software are working behalf of a trusted people. So here just we have provisioning and authentication words. For that meaning here, the provisioning is the process of enrolling a device into the system. Authentication is a step in that process of provisioning whereby you verify that only devices with the proper credential get enrolled. So this is the first that is one, provisioning and authentication. Next, configuration and control. So it is deployed out in the field, whether that is a tracker on a mobile asset like a car or a sensor, for remote monitoring like a refrigeration system. After deployment, there may be configurable device setting that you want to adjust over time, such as decreasing the frequency with which your trackers report positioning managers to increase battery life. The ability to configure and control devices even after development deployment is therefore critical to ensuring the functionality of the IoT devices. So this is the configuration and control. And monitoring and diagnostics here. In addition to configuration of the device, certain device settings, there may be also be unforced operational issues or software bugs that you will need to address. But to address them, you need to identify them in the first place only. So this is the device management software can provide program logs needed to make diagnosis. So this is the third one. Last one, software maintenance and updates here. If you identify a bug with your device and a secure flow of, you will need to be able to make updates a device software from AFR with thousands or millions of devices getting physical access to each device to update them manually. Just it's not practically possible. So if possible, if physical access is required, your IoT solution may be doomed at least very brittle and precaution in the long run. So these are the four kinds of IoT device management system in order to maintain the device in the IoT device in the network. So these are the four: provision and authentication, configuration control, monitoring and diagnostics, software maintenance and update. So next we have another topic. The question bank is on simple network and management protocol. So here what is shortly SNMP? It is SNMP is a framework used for managing devices on the internet. It provides a set of operations for monitoring and managing the IoT internet. So the SNMP, Simple Network Management Protocol, the main aim of that Simple Network Management Protocol here, it is used for managing all the devices on the internet. It can provide a set of operations to monitoring and managing the device. So by passing the code, it can be able to control like that. Just we have to assume here. Simple Network Management Protocol is a standard protocol that facilitates the exchange of management information between network devices and central management stations like that. In operates in client server model where the managed devices such as routers, switches and servers are the server and management station is the client. So SNMP manager here through the SNMP, it is the agents, router, server or multiplayer switcher like that. So this is the just block diagram of simple network management protocol. So these are the some protocols here. Process what is protocol just is used to develop and what is the port number. Process request recipient by the agent, it is the user datagram protocol, the port number is 161. Managers communication with the agent, that is UDP and 161. Notification recipient by the manager here under the user datagram protocol and 162 is the port number, and the agent's notification generation UDP and any available port just it can connect to the internet network. Request to recipient here by using datagram transport layer security, that is the TLS or DTLS, the 10161 is the port number. Notification recipient by using TLS or DTLS, transport layer security, that is 10162. These are the network simple network management protocol list with the help of process. Here there are mainly three components of SNMP here. SNMP manager, as we discussed in the last slide, the black diagram itself, SNMP manager, agent, MIB, management information base. The manager just used to it is also known as network management station, NMS. A router that runs the SNMP server program is called an agent, while a host that runs the SNMP client program is called a manager. Agent is nothing but it accesses the values of stored in the database, whereas the agent maintains the information in the database. So that is the second one. The MIB, management information base, it consists of information on resources that are to be managed. This is information organized hierarchically. So the MIB object to hold these groups only. So these are the main components, and the concept. What is the concept involved in that? It is an application layer protocol in which a few managers stations can handle a set of agents. The protocol designated at the application level can monitor the devices made by different manufacturers and installed on different physical layers. So this is the manager TCP by using TCP/IP protocol. It is the agent under the agent variable. So this is the small concept of SNMP. Management components. So here SMI, one of the component, MIB component, SNMP component. Again, these are the three protocols such as abstract notation of one and basic encoding rules. This is the structure of management information by MIB. Just we have some different protocols. A system, IFU, yet IP, ICMP, TCP, UDP, and UGP. So these are the some MIB is categorized in eight groups. The 8 groups are this one: system, IFU, system interface, address translation, IP address, ICMP, TCP, UDP, EGP. So these are the some groups under the MIP. So SNMP message, which type of it is message? It can request and sender, get request, get next request, set request, response, trap information request. So these are the SNMP manager messages under the MIP. And security levels we have here. 3 types of security levels: no authorization, no authorization, and no privacy. No authorization and no privacy. So authorization and no privacy. Next to authorization and privacy. So these are the 3 types of security levels which is provided by the SNMP. So here no authorization, no privacy level means security level uses a community string for authentication and no encryption for privacy. So this is the next one. The security level uses HMAC with MD5 for authentication and no encryption is used for the privacy. So these are the security levels which are available in the SNMP, and these are the limitations of SNMP. Very important to know. Configuration validation, configuration database schemas, configuration comparing role based access control, consistency of access control list, multiple configuration sets, and support for both data oriented and task oriented access control of the network. And versions of SNMP here: SNMP PV1, SNMP PV2C, SNMP PV3. So these are these different versions of SNMP. Based on that, RFCC just we use RFCs 1155 and 1157. So here SNMP PV2C is RFC 1901, RFC 1905, RFC 1906, all describe the data. And here is SNMP PV3 here, RFC 1905, RFC 1906, RFC 2571, RFC 2572, 2574, 2575, 0.6 are the RFCs for SNMP PV3 versions. So these are the different versions under different protocols here: SNMP PV1, SNMP PV2, SNMP PV3. So these are the references I used for this lecture. Along with this, I used standard textbook for on internet, some SCI paper and some Scuba papers also I referred for this lecture. These are the references. Thank you. Continue with the next lecture.
Like, share and subscribe. Hit the bell icon for more updates.